Okay, on to question 11, which is a nice circular measure question at the end of the paper. Part 1 is actually a little bit tricky, so I can understand why you guys have voted for this one. You've got to show that x equals 7.218. So it's not immediately clear how to do this. So I'm going to start by analysing the situation. When I look at the diagram, and I look immediately at that value for x. I know it's the radius of the circle. My first thought would be, okay, have they told me what the perimeter of the circle is? No. Can I find the perimeter of the circle easy? No. Have they told me what the area of the circle is? No. Have they told me anything else that could help me use the area formula to work backwards to find the radius? No. So I've ruled out two of the formulas that I know that have a radius in them. And I can't use that to help solve me for this problem here. So then I've got to go a little bit further. So what I notice is that if I was to take my value of x here, the radius, and rotate it around, it would be the same distance from C to O as it is from C to R. Okay? And then what happens with circles and tangents to circles is that the radius and the tangent at that point make a right angle. Okay? Right there. Which means if I just turn that around for a second, what you'll see is what I have is a right angle triangle, because I can connect up that point at the centre of that small circle back to O, and I've made a right angle triangle. Okay? So let me just rotate that back around. Let's just draw that right angle triangle for ourselves down here. So it looks like this. It's got that right angle. The height of that right angle is the same as the radius of the small circle. So it's x. And the angle at the bottom there is 0.6 radians, because it's half of 1.2. So it looks like it's a right angle triangle. I can start using some sort of trig or Pythagoras with it. In this case, it'll be trig because it's got an angle. But I need another side to go with it. So I look back at my diagram here, and I need either the hypotenuse or I need the base that I can solve for this value of x. The only other numerical information I have on this diagram is that the whole length of this radius of the big sector is 20 centimetres. Now, I'll just rotate this back around again over here. I can't assume that R is halfway along. They haven't told me that R is a midpoint, and there's no other kind of rules that would make me think it's a midpoint. Okay, so I can't do that. So then all I can do is look at this side of my right angle triangle, which is the hypotenuse. And what I know is that from Q to O, all the way from there to there, has to be the same distance as the radius. So it has to be 20 centimetres. Now, I know that part there is x. That means the part that's left over, which is my hypotenuse, has to be 20 minus x. I rotated my 20 minus x at the same time. Is not what I expected. I'll write it back down here again. Right. Okay. And now it's cool. Now we've got two sides of a right angle triangle, and we have an angle, so we can use trigonometry to solve it. It keeps on moving around. It's so annoying. Right. So what have we got? We've got opposite over hypotenuse, so we've got a sine function. So let's set that up. So it's going to be sine of 0.6 equals the opposite, which is x, over the hypotenuse, which is 20 minus x. Okay, so if I work out sine of 0.6, making sure my calculator is in radian modes, I'm going to get 0.564, and I'm going to go for one more dp. My final answer is supposed to be 3 dp, so I'm going to go one more before my rounding. That equals x over 20 minus x. If I multiply both sides by 20 minus x, I'm going to get 11.2928 minus 0.5646x equals x. And then if I collect like terms and divide through by x, I'm going to end up with the answer, which is 7.218. I mean, that one is quite a bit harder. It's quite hard because it involves some tenacity there to launch into a question where you have not much information and have to still form some sort of equation using the relationship. So that is quite a tricky one that's popped up in the last few years. Yeah, and so for part 2, we just have to show the total area of the 3 parts outside the circle. So that's going to involve us doing the area of the sector and then taking away the area of the circle, so that what's left over are those 3 parts on the outside there. 1, 2, and 3. Let's start off with the area of the circle, because that's pretty easy. The area of a circle is pi r squared, and in this case here, the r squared is the answer that they've given us before, which is x. So 7.218 all squared. So that's the area we're going to take away from the larger area, which is the sector area. And the sector area equals half theta radius, so half of 1.2 times the radius, which is 20, which equals 12. So my total area equals 12 minus 7.218 all squared pi, which comes out to be, I just spotted a mistake as I got a negative answer for that. What was my mistake? It's half theta r squared. There we go. So that should be 240 there. Okay, so that makes this part here 240 as well. Fortunately with that one, you can spot you've done a mistake because you would have got, like me, a negative answer. Or you just use the formula sheet rather than just try and do it from your head like I just tried to do. Anyway, so then our final answer is going to be 240 minus 7.218 squared times pi, which gives us 76.3, and that's to 3 sig fig. Okay, on to the last part. So we have to find this perimeter of OPSR. So what's really important is that we know which part exactly we're talking about. So we're talking about this part, and this part here. So those 3 parts there. Right, so let's start off with the curved part of that. So the arc from PSR. So what we need to do is get that looking like it's part of a circle. And so which circle it's part of is the small circle, which is the centre of C. So if I join up from, always a different colour, sorry. If I join up from C to P and C to R there, I need to know what the angle is there to be able to use the arc length formula. So, what we know is that these opposite angles here are going to add to 180 degrees, or in this case pi, because we're in radians. Why do I know that? I know that because we already looked at the fact before that the radius and the tangent make a 90 degree angle. So that would be 90 degrees there, which means it's 90 degrees over on that side as well. This is the quadrilateral, so quadrilaterals have to add up to 360 degrees. So that's 90, that's 180 of it, so the other 180 has to be shared between those 2 angles. Or in this case, it's going to be pi. So this angle here is just pi minus 1.2, which is, we'll leave it like pi minus 1.2 in our equation. So we're not rounding too early. The radius of the circle we know from before is that it's 7.218. So if we put that all together, the curved edge of that perimeter is the same as 7.218 times pi minus 1.2. And I just haven't evaluated that because I don't want to round too early. I can do it all on the calculator in one step, and that's probably the safest way so that you don't make it inaccurate until right at the end. In this case here, they haven't asked for an exact value. If it was going to be an exact value type question, they would have to give you nicer numbers and nicer angles to play with, so it should come out to be exact values. So in this case here, that arc length is going to be 14.0144. I'm going to keep lots of decimal places and wait till the final, when I've got the final perimeter before I do any rounding. Okay, so that is the curved edge there, done. What I need now is the two straight edges part of it, and I'm going to use my right angle triangle again. So I'm going to cut down the middle there, and if I rotate that around, you can see my right angle triangle. Hopefully you can see the right angle triangle there again. Okay, so I'm going to use that right angle triangle again to work out, this time, the base. So I already know that the height of that triangle is 7.218. I know that the angle there, again, is half of 1.2. It's 0.6. And what I want now is this base here, which is the length OR. So that's a trig ratio. It's tan. So tan of 0.6 equals the opposite, which is 7.218 over the adjacent. Okay, so the adjacent side is going to be 7.218 divided by the tan of 0.6. And make sure your calculator is in radians mode before you do this, otherwise your answer will be wrong. And that comes out to be 10.5505 and some other stuff. I need two of those, so I'm going to double that. So my final perimeter is going to be the 14.0144 of the curved edge plus two lots of this 10.55055 stuff, which comes out to be 35.1 if I round to 3 sig fig.